Hi, I'm Anthony Smith from Calex Electronics, and I'd like to show you the Pyro NFC, which is the world's first NFC configurable infrared temperature sensor. It's designed for industrial, test bench and laboratory applications for measuring temperatures from 0 to 1000 degrees C. It's a non-contact sensor that works by detecting the infrared radiation that's emitted by surfaces as a result of their own temperature. It provides an output of 0 to 5 or 0 to 10 volts DC, that's a linear analog output, and it also has the ability to be configured using an NFC smartphone. The Pyro NFC is our smallest sensor yet. It measures only 29 millimeters long. Now if you compare that to the Pyro couple, one of our other sensors, this one's 103 millimeters long. That means the Pyro NFC is going to fit in much smaller spaces. On the front of the sensor, we have a lens for gathering the infrared radiation and two mounting holes. The mounting screws are provided. On the back of the sensor, the NFC active area. Most infrared temperature sensors need to be configured in some way, whether it's changing the emissivity setting, applying averaging, or rescaling the voltage output. There's no need to add an extra configuration interface or extra hardware and software if you've already got a configuration device in your pocket. You can configure the Pyro NFC with an Android smartphone with NFC near-field communications. The Pyro NFC app is available free of charge from the Google Play Store. Once you've downloaded it, you can open it simply by touching the sensor with the NFC device. You can switch between degrees C and degrees F, and you can rescale the temperature range of the linear voltage output. You can also configure the open collector alarm output for set point and hysteresis. The emissivity setting of the Pyro NFC is adjustable so that you can achieve an accurate reading on a variety of materials. Also, if you're aiming the sensor into a furnace and you'd like to compensate for the reflected energy, you can enter the reflected temperature here. The sensor has a response time of 0.125 seconds. You can slow that down by applying averaging here. If you're measuring the temperature of individual objects on a conveyor, peak or valley hold processing will allow you to ignore the gaps between them. To save the settings to the sensor, simply tap Write to Sensor and then touch the sensor with the phone. You can read the settings back from the sensor in much the same way. The sensor doesn't actually have to be connected to the power to read or write settings. That makes it very easy to configure. If the sensor is connected to the power, you can read the measured temperature by holding it against the sensor.